Question number 30. A fair coin is tossed once. It says A is heads, occurs B is tails. They want to know, are these independent or dependent? So probability of A times the probability of B equals the probability of A and B. Well, the probability of getting a heads is 1 out of 2. Tails is 1 out of 2. When are they both going to happen? Never. So we end up with 1/4 does not equal 0. So these are dependent. 31. A fair 6-sided dice is tossed. So I'm actually going to go back and grab my table that I made earlier. It wants to know what's the probability of a 5, and then the second one is the probability of the sum of 7. Looking for 5 and sum of 7. So if I go back and look at my table, the probability of getting a 5 is along, actually it's just one of the die is 5, so that would be all of these 6 cases right here. So I have a 6 out of 36 chance, which is 1/6. The probability of getting a sum of 7 is all of these in here, so 1, 2, 3, 4, 5, and 6. So again, 1 out of 36, which is 1/6 times 1/6, which is 1/36. Now I'm looking for when one of my die is 5 and I have a sum of 7. So one of my die is 5 and a sum of 7 happens again, 1 out of 36. These are independent. Alright, moving on to question 32. Wants to know, determine if these two events are independent, randomly choosing 2 socks one after the other when the socks is replaced. So on 32A, if the sock is replaced, that means these are independent because the probability of the first one is not affecting the probability of the second one. Question B, if it is not replaced, that means the first probability turns around and changes the second probability, so that would be dependent. Alright, next we're going to skip to question 36. We flip a coin and we roll a die, so they want us to list the sample space. So I could get a heads and a 1, or tails and a 1s. Heads 2, tail 2, etc. So this is a 5. Okay, question B. List the outcomes in the event the coin shows a head or the die shows a non-even prime number. So I want the probability of a head plus the probability of a non-prime number, but it has to be even. And then I'm going to subtract anytime I get a head and that non-prime even number. Okay, so the probability of getting a head is all of those, so that would be a 6 out of 12. The probability of a non-prime but even number, so even would be 2, 4, and 6, but I want it to be non-prime, so that would be the 4s and the 6s, so that would be 4 out of 12, and then I'm going to subtract when they overlap, which would be these 2 cases here, and finally we end up with 8 out of 12. And I guess all they wanted is to list the outcomes, so that would be, here's all the heads, and then we'd be adding in these 2 right here. How many outcomes are in the event the die shows a number less than 3? So that would be any of these in here, and they want us to just know how many 36C, there are 4. Alright, moving on to question number 43. What is the probability of guessing correctly on exactly 4 of 5 multiple choice questions with 4 options on each? Skip 43 for the moment and come back to it. Let's go down to question 44. What's the probability of 4 consecutive days without rain? The probability of rain in a particular day is 0.3. So I want probability of rain is 0.3, so the probability of no rain is equal to 0.7, and I want 4 consecutive days, so that's 0.7 times 0.7, 0.7, 0.7. Alright, and when we multiply that, we get 0.2401. Moving on, question number 48. What's the probability of correctly pairing 4 locks with their keys from a box of 9 keys in the first try? So we are doing first of all, there's only one time that's going to happen. You've got 9 numbers and we are selecting 4. So we get 1 out of 3,024. Question 49. Emma's school uniform allows for 3 different skirts, 2 different pairs of shoes, and 6 blouses, so we end up using the counting principle, and there's a total of 36 outfits. Question number 50. How many ways are there for him to file his papers by subject in different folders? So we've got 8 different colors, but all we need are 5 colors. Alright, 8P5, we end up with 6,720. Question B wants to know how many ways are there for Philip to order his 5 subject folders. So in that case we have 5 folders and we are ordering them all. So that's 5 times 4 times 3 times 2 times 1. We end up with 120. And finally it wants to know, utilizing those, how many total possibilities does he have? So we end up with the 6,720 times the 120. Alright, last question. Question number 51. How many different ways are there for a 6-player volleyball team and their coach to line up in a row for a photo if the coach wants to stand at one of the ends? Okay, so if you can envision, you've got a photo. The coach wants to stand here, and you've got 1, 2, 3, 4, 5, 6 players here, so that would be 6, 2, 6. Or you have your 6 players here, 1, 2, 3, 4, 5, 6, with your coach at the end, which again is 6, 2, 6. So 6, 2, 6, you end up with 720 here, or we have a 720 here, and finally we end up with